Explain like I'm 5. Why do galaxies look like they spread out in a single plane? I.e., why do they look more like frisbees than spheres? Everything in the universe is spinning, including galaxies. Galaxies start out as big spheres of gas. All those particles are orbiting around the center of the sphere. Some of them might be orbiting almost vertically, while others are orbiting more horizontally. Over a very, very long period of time, these particles crash into each other. And when they do, they cancel out the different directions that they were going in and start going in the same direction. Conservation of angular momentum. So eventually, most of the things in the galaxy end up going in the same direction, because the stuff going in different directions crashes into each other. Imagine a spherical ball of gas and dust, where each individual particle is traveling on a circular orbit at some random angle relative to all others. Sometimes, the particles will collide or interact, and the result will be that they lose some energy along their path, or even stick together. If they collide head-on, the motion of one can basically cancel out the motion of the other, and those particles functionally stop orbiting. They'll fall to the center of the cloud. If the cloud is dense enough, most of them will do this. But what if the orbits aren't totally random? What if the majority of the particles have some component of their motion spinning around in the same direction? Well, then when the particles collide, their orbits won't totally cancel. The up and down parts of the orbits will, but the sideways components will add up. The result is, over time, the cloud will collapse down into a disk, spinning in the direction of the slight overall spin of the cloud. Take a ball of dough and spin it. What happens? It turns into the shape of a pizza. Why wouldn't that also happen in space? Great question. It is one of the effects of gravity in a 3D space. Before they are galaxies, they are giant masses of gas spinning around some axis. With time, gravity pulls objects towards each other, making it look more like frisbee and less like a sphere. Elliptical galaxies, spherical, ovoidal types are more abundant than disk galaxies. IIRC, it's due to the way galaxy merging happens, while the other is due to conservation of angular momentum and central forces. Everything is pulled equally towards the center of mass by gravity, but that force is only resisted by spinning. The spinning can only occur along a single plane because more than one plane will cause the objects to collide with each other. Everything averages out in the end and you get a disk. You ever see someone throwing and rotating pizza dough in the air, and as it rotates it flattens out mid-air? Galaxies are just giant pizza doughs. For the same reason why if you toss a ball of dough, you can make a flat pizza. When things spin really fast, they flatten around the rotation axis. Galaxies do the same. Try stirring a cup of tea really fast, then dropping a bit of milk in. The milk will fall to the bottom initially, but the continuous spinning of the stirred tea will draw it in, so the milk eventually spins with the tea. Something I haven't seen explained yet, which is crucial to understanding this. Nothing can spin on more than one axis at a time. Say you have a ball floating in the air before you. You spin the side facing you downward. Now the axis of rotation is a horizontal line in front of you. Try to add a spin to the right at the same speed, and you don't have two different spins. You have one spin diagonally downward and to the right. Thus, spin forces cannot create a sphere. They can only create a disk shape. When you spin around in a circle quickly, and feel your arms being pulled outward, do they get pulled straight outward when they're relaxed? Or do they fly all over the place? Also, galaxies generally spin one way. If they spun more than one way, then objects would collide. Same reason ring systems are flat, right? Ever whip a soaking wet tennis ball? Notice how, if you get decent spin, most water will behave the same. Kind of the same principle. Imagine having a ball attached to a string. If you were to spin the ball outwards holding the string, you'll notice that the ball tends to circle around on the same plane. And it requires force to change the ball's spin plane.